about the economics? Can any of you guys speak to the economics of different approaches to delivering IT services?
So I think there's several different ecosystems you can think about when you think of cloud. So basically people are coming from two places, right? You're either coming from the Amazon world where you understand that you can get these resources on demand and you have a set price point in your head, or you're an enterprise who's coming from a VMware world, where you're used to paying for enterprise hardware and you're used to paying exorbitant licenses. And one of the things that Amazon has shown us is there is a specific model for how to deliver these services. So whether you're going to be running it private or public, there is a clearly delineated path for how you should be building these clouds and how the economies of scale work, right? So you use hyperscale hardware. Dell is a big leader there.
What do you mean by hyperscale?
Hyperscale is where you have compute and storage on the same blade, very modular design. So instead of having a blade server where you have a shared backplane, each of your computes reside on a single blade. So everything is on one central location. So it's very modular. It can tolerate failure. So that's how you have an assumed failure model. You can build it into your system. So in cloud, everything is going to fail at some point. But you stop thinking about the physical resources as being the necessary components, right? So instead of buying something that's wildly expensive that'll never fail, yet always ends up failing because machines fail, you buy things that are cheap, commodity hardware, and you build redundancies into your system. Okay, so in essence, one more thing, and then you use open source, right? So open source is the way to do this, and you need to have that as a part of your strategy when building a real cloud.
Okay, so one of the key features from what I'm hearing you say is that there's this separation of the physical server from the virtual server, right? And so like Google, for example, has software that just routes around if a server dies. I'm sure that other people are doing that as well. And that, even though it sounds like a great thing from a software perspective, but it actually has resource and cost implications as well, because you no longer need to have two power supplies on a server. Because who cares if a server goes down, right? You're no longer saying reliability is this application running on this server has to continue, right? And that's a big, important feature of these kind of cloud environments. Any other comments on that?
Yeah, I mean, sorry, I just have a lot of comments about these things. So I think about cloud, you know, and this is a broad IT trend for the next 20 years, right? So we're just at the start of this. And the amount of innovation and change that we're going to see is going to be totally massive. Everything is going to be upended. And I think about it kind of as an inverse pyramid, where right now we're just seeing the little tip, and it's just about the efficiencies that we're getting out of hardware. But when you start to save time on people's efficiencies, right, and your application uptime, these are massive savings for businesses, right? So instead of having any kind of failures, like you don't think about massive web scale companies having failures in their systems. Like Amazon doesn't go down.
Ooh.
In terms of, no, I mean
Amazon.
Amazon.
I don't know if I agree with you on that one.
Yeah, hold on.
Amazon.com, right? So Netflix, right? When Amazon Web Services went down, Netflix did not, right? There was a lot of services that have been built on top of these clouds where if you architect it to assume failure, then you will be fine. And that's part of the education process from there. I'm sorry, Amazon will go down. You have to architect correctly. That's a whole other conversation. Happy to have afterwards.